Good morning, 5th graders. It's Mr. Mace again, and I'm here to walk you through Unit 4, Lesson 9. Again, kind of building on our multiplication theme and continuing to work with ideas with multiplying both whole numbers and decimal numbers. I don't expect this to be an extremely hard math lesson, but in teaching this over the last handful of years, guys, I do find that this is a lesson that students tend to make a lot of silly mistakes on because they're rushing, because they feel it's actually very simple. This will be a 2-video lesson again. I'm going to break this up into 2 separate parts, so hopefully you will watch both of these because there are 2 fairly separate concepts that I'm going to cover in these 2 videos. The first one here is, again, more just about the why we multiply, or when we multiply, what happens. All right. So these first couple of story problems up on top, or these fill in the blanks where we have a sentence that we're filling in the answers to, pretty straightforward stuff. But like I said, it's more about the understanding why when I multiply by a whole number, my numbers get bigger, and why when I multiply by a decimal number that is smaller than 1, my number will actually get smaller. Okay, so just kind of wrapping our mind around the why here. And like I said, when we get to the bottom portion of this page, you're going to see why I think a lot of people make some silly mistakes. And like I said, just try to make sure you are taking your time and you're answering the problem like we know how to do at this point. All right, so problem number 1 says when you multiply by 10, the number gets bigger. How much bigger? Well, pretty straightforward. Multiplying by 10 means it's going to get 10 times bigger than it was before. Okay, and this is where we really start when we talk about digit shifting. This is one of my, I wouldn't say my least favorite aspects of this book, but it gets kind of confusing because a lot of teachers talk about moving the decimal point, and the books or some other teachers talk about moving the numbers, and I think each of us wraps our mind around it differently. Okay? The biggest thing I want you to identify here is that when we multiply by 10, the numbers will get 10 times bigger, which means the digits are going to move one spot. There's 1 0 and a 10, so our digits are going to move one spot. In this case, the digits are moving to the left, because if we look at a number line, left makes numbers larger. Okay, 1 is right next to the decimal point, and if I move that one spot to the left, it's 10 times larger than it was before. Okay, now if I go across to 2, I'm multiplying by 1/10, 0.1. Okay, and we said that that number is smaller than 1, so it's going to have kind of the opposite reaction. When you multiply a number by 0.1, or 1/10, the number is going to get 1/10, and then I'm going to represent it as a fraction just so we can see the relationship between those two numbers as well. It's going to get 1/10 as great. Now they say as great, but we know that actually makes the numbers smaller because fractions make numbers smaller. Fractions are smaller than 1. The digits are still only going to shift one place value, and I know that because I have one number behind the decimal point. But in this case, my numbers are going to get smaller, so the digits are going to move to the right. So the opposite of what we said on the last problem. All right, so if we look at this, there's a lot of similarities. You can see the 10 and the tenths. You can see the 1 and the 1. We're only moving one place value. The opposite, though, is case. We move, when we get bigger, the numbers move to the left, and when we get smaller, the numbers move to the right. All right, well, the same thing is true for 3 and 4 down here below. Now we're multiplying by 100, and you can see that there are 2 zeros in 100, which means the number is going to get 100 times larger. Okay, 100 times greater. But in this place, we're going to move 2 place values because 100 has 2 zeros. So it's going to get 2 spots, 2 place values to the left, getting bigger again. We're multiplying by a number greater than 1. But if I look to 4, I'm multiplying by 0.01, which is also stated as 1/100th, THS, or hundredths. Okay? So it's going to get smaller by 2 place values. So we're going to move those numbers 2 spots to the right. All right, so hopefully that makes sense to you. So question 5, I'm not going to write anything out for it, but I'm just going to kind of explain it to you. It says, how is multiplying by 10 or 100 like multiplying by 0.1 or 0.01, and then how is it different? How they're alike is the number of place values we're going to move is exactly the same. 10 and tenths means we're going to move it one place. Okay, 100 and hundredths means we're going to move it two places. Okay, there's two numbers behind the decimal point, or there's two zeros on the back of 100. We're moving it two spots. The difference is the direction in which we move it. Okay, if our number is bigger than 1, our 10, our 100, our 1,000, those numbers are going to shift to the left. Okay, they're getting bigger. Or if I'm multiplying by a decimal number, something smaller than 1, 0.1, 0.01, 0.001, those numbers are going to shift to the right. So it's all about the thing that's the same as the amount of place values. The difference is the direction in which they're going. Now, this, like I said, is where a lot of kids make some silly mistakes. And this is where I will really stress the need to focus on what we're doing here. And looking, now if you look at that entire first row, 6, 7, 8, and 9, we are including the same numbers all the way across, okay? And so people automatically then assume, oh, this is really easy, I can move it. But, okay, understand to me the process that we've talked about now for about a week and a half. For problem number 1, solve 36 times 10 before you worry about where the decimal point goes. All right, just solve 36 times 10 because that would be a normal multiplication problem with a decimal in it. Just solve it without the decimal and then throw the decimal point back in. And that's the biggest thing I can state to you right now. So if I say 36 times 10, that should get me to an answer of 360. Okay, hopefully everybody can agree with where that's coming from. Now I look back into the problem and I identify that there is one number, the 6, behind a decimal point in that problem, which means then I need one number behind the decimal point in my answer, which is in this case is the 0, so my answer becomes 36 or 36.0. You don't need the 0 behind it, doesn't change the number. All right, hopefully that makes sense to you. Now, same thing for the next one. We see a bunch of fancy window dressing there. I still see the 36. I still see a 1 and a 0, but those are changed, and I see an extra decimal point. That's all just kind of, like I said, window dressing. That's all extra. Solve it like we know how to solve it. What is 36 times 1? Forget about the decimals until we solve the problem first. So in this case, the 0 being in front of the decimal doesn't do anything. It's not, doesn't need to be there. I don't need to add anything with it. This problem is essentially 36 times 1. Well, 36 times 1 is 36. Now, I go back and I check how many decimal point place values are in the problem, just like yesterday's lesson. How many are in the problem? Those need to match how many are in my answer. So in the 3.6, I see the 6 behind the decimal, and this one, there was a decimal point in front of the 1, so I have two numbers behind the decimal point in my problem, which means I now need two numbers behind the decimal point in my answer. That'll be the 6 and the 3, so the decimal point goes in front of the 3. In most cases, most teachers or a lot of teachers will expect you to put that 0 in front of the 0.36. Again, I think we enter it in Schoology either way, 0.36 or just 0.36 are acceptable answers. All right, now I look at 8. Again, I see the same numbers involved. I see a 3, a 6, and a 1. But in this case, that 1 is in a different place value. I've got a different number of decimal point place values again, so that's what we're really focusing on here. Again, solve the problem first without worrying about the decimal. So in this case, it's 36 times 100. Well, 36 times 100 is 36 with two zeros behind it, because the 100 has two zeros, so my answer needs to have two zeros. That hopefully makes sense to you. And then I go back up and I count my decimal place values. In this case, there's only one number behind the decimal, and that's in the top number. That 6 again is behind the decimal point. So that means in my answer I need one number behind the decimal point, and that will be the second 0. So my answer is then 360. Now you can see the similarities in our answers, right? But you can also see how different they are. I've got a regular 36, I've got a 0.36, and I've got a 600 or 360. Okay, so there's a lot of variety in our answer, even though those numbers really haven't changed much. It's all about decimal point place value, okay, or decimal point, and which establishes our place value. All right, and then the last one here, same scenario. Again, a bunch of fancy window dressing. This 0 doesn't even need to be there. because it's in front of the decimal point. Now the second one does in terms of how we're going to place that decimal point at the end, but in all honesty, to solve the math, it's still just 36 times 1. Well, 36 times 1 is still just 36. Now again, I look at the problem and determine how many numbers are behind a decimal point in the problem. 1, 2, and in this case the 0 does matter because it is behind the decimal point. So 3 numbers in my problem behind the decimal point, which means I need 3 in my answer. And this is where it does get a little confusing, 5th graders. The 6 is behind, the 3 is behind, but that's only 2. So that means I need to do something to my answer to make this a true statement. In this case, I do need to add a 0, not behind, but in front of the 3, 6, because that 3, 6 needs to end in the thousandths place. So when I add a 0 in this case, I need to add it to the front. So those are my 3 numbers, just like in the problem, 1, 2, and 3. 3 numbers behind the decimal point. So my answer for this one then becomes 0.036. All right? Now you can see how it's relatively easy math. 36 times 1 is a pretty easy math problem to do. But where the confusion comes in is, where is that decimal point going to go? How big is my number going to get? And you can see though, guys, when we're multiplying by those whole numbers of 10 and 100, those numbers bigger than 1, our answers have gotten bigger. 3.6 has turned into 36, or it's turned into 360. And you can see when we're multiplying by the decimal numbers, 0.1 and 0.01, how our numbers, 3.6, got smaller. A smaller decimal number. So hopefully that makes sense to you. Now I'm going to skip that middle row only for the simple fact that we're continuing to multiply by 1, but it doesn't matter. It's the same basic concept for the bottom row. We just change it to be a little bit more difficult, I guess is the right word, but we're not multiplying by 1. All right, so problem number 14 here. We're looking at this, and again, I see a decimal point number, but this is very much like our lesson from yesterday, guys. Solve the multiplication first. Won't worry about the decimal point. So 6 times 2 is 12. All right. Then I go back and I check how many numbers behind the decimal point. In this case, there are 2. 1 and 2. My decimal point will be in front of the 1. If I throw the 0 in front, that makes it look a bit more logical. So that answer should be 0.12 or 12 hundredths. Number 15. Okay, again, kind of in the wrong order, but again, if I think about how I solve these problems, 3 times 9 is 27. I have 2 zeros in 300, so I throw 2 zeros behind it. 300 times 9 gets to be 2,700. Now I go back up to my problem. I figure out that there's only one number behind the decimal point in this case. That's the 9, which means I need one number behind my decimal point in my answer, which is the 0, and so my answer is 270. All right, hopefully that makes some sense to you guys. I would like you to attempt a few of these problems in between videos here. So I'm going to leave 16 and 17 for you to do. I would also like you to attempt 10 through 13. So just very simple, 6 problems. I'm probably not going to give you all the answers when we come back out, but I will give you the answers to 16 and 17. I'll probably give you the answers to 10 and 11, but I do have another pretty large, significant concept that we're going to cover in the second video. So I want to make sure that we are feeling and giving ourselves enough time to answer those concepts or those questions in the second video. Good luck with your work. Please do them before you click on the next video so you can test yourself and then check your answers with what I give you.